Hi everybody, we're back. It is time for math, Mr. Schmidt.
Time for math.
Maggie, are you here for math?
She's been
Maggie's ready for some math. Okay, guys, you are getting off so stinking easy today. I cannot believe how easy, Callista. Okay. At-home activity, materials, measuring cups, paper bag, pencil, paper. Guys, it says measuring cups. You do not need measuring cups. You can use measuring cups, which will make it fun.
You need something with fractions on them.
Yeah, so
right?
you can look at this. You can write it on paper, put it in a bag. You could do whatever.
And they have the fractions 1/8, 1/4, 1/3, 1/2, 3/4, and 1.
Yeah. Yeah, so it's pretty easy. I'm just saying if your mom doesn't want to let you use her measuring cups, you don't have to have measuring cups to do it. You can do it with anything, put the measurements on it, and use it. So it says, place the measuring cups in the paper bag, hold the bag closed, and shake so that the measuring cups are mixed up.
It's going to have to be kind of a big bag.
Yeah, it would have to be huge, like a shopping bag.
Because measuring cups take up a lot of space if you take them apart.
Shake them around. Yeah. Okay. Without looking, select 2 measuring cups from the bag. Multiply the 2 measurements. Check your student's work and place the measuring cups back in the bag. Okay? Without looking, select 2 measuring cups from the bag. Divide the 2 measurements. Check your student's work and place the measuring cups back in the bag. So, I thought we would practice, Mr. Schmidt. Shake your imaginary bag.
Okay, let me use the mouse. Okay, I'll use this one.
Okay, 1/3.
I got 1/3.
Okay, let me get my pen, make sure it's working. Okay, so I'm going to say 1/3. Okay, Mr. Schmidt, pick another one.
Okay. Kevin! Never mind.
Kevin isn't caring.
Kevin's wearing his headphones.
Okay,
so how about 1/2?
Okay, so 1/3, we're multiplying. So 1/3 times 1/2. Okay, so can we simplify? No. So 1 times 1.
What she was thinking was, could she cross cancel anything
Thank
or cancel anything?
No, I couldn't.
You were thinking, but you didn't tell him what you were thinking.
Yes, I lost my word. 3 times 2 is 6. So 1/3 times 1/2 is 1/6. So if we multiply, that's what we would have. Now dividing. Let's divide.
Okay, so I'm going to say, let's say I pick those same 2 fractions.
Okay.
But I'm going to reverse them now.
Okay, so
let's have 1/2.
1/2
divided by 1/3.
Divided by 1/3.
And you guys are actually supposed to use the bag again. You know,
yeah.
I don't want to use up all the fractions. So
yeah, no kidding.
We'll use these 2.
So we're going to do this here, and we know that my rule, leave it, change it, change it.
Ooh, you're
yeah,
going to have to
it's
lower
up
that.
there.
Yeah.
So let me put it down here. Leave it, change it, change it. So what we're doing right here is we are leaving the first fraction the way that it is. We're changing the sign, so the opposite of division is multiplication, and then we're going to find the reciprocal of 1/3, which means we're going to flip it over and say 3/1.
Okay, so I have a question real quick.
Yes.
How do you get your students to remember LCC, leave it, change it, change it? How do you get them to remember that pattern? Because I could see some kids in my class having trouble remembering that.
We just recite it each time. They pick it up pretty quickly, honestly.
Okay.
We've always had it. I know they have it in their brain. Leave it, change it, change it. Leave it, change it, change it. So, can we cross cancel? No. So, now it's a multiplication problem. So, it's 3/2. And we know that it's an improper fraction. So, we're going to kick it off and divide. And so...
She's wondering why I'm laughing. I'm just thinking, I always like to think of funny things with the letters.
2 goes into 3 one time. 1 times 2 is 2. Subtract. And I have 1 left over. So my answer is 1 1/2. Okay? Is that good, Mr. Schmidt?
So you're telling me that there are... Okay, 1/2 divided by 1/3 equals 1 1/2. Okay, and I'm just following how you got it. Okay, so you flipped the fraction, you did the reciprocal, and you multiplied, and you got 3 over 2, and 3 over 2 is 1 and 1/2. Yeah, okay.
Thank you. I'm so glad. All
Well,
right.
how mean.
Oh!
Did you hear the sarcasm in that,
Oh
you
my
guys?
goodness! I want you to know I got an orange crush by mistake.
Oh, there she goes, lying again. She has a cherry Pepsi. Okay, so I'm just going to draw. Okay, we have 1/2. So imagine that this is 1 whole, and here we have 1/2. So how many thirds could we get out of that? We could get this third here, right? That would be, here would be another third, and here would be another third. So we have actually a third here, and a part of a third there, right? A half of a third, right? Because the other half would be over here. Okay, so there's 1, and then down here there's 1/2. I just wanted to visualize it for myself. Okay, I'm good. 1 1/2.
Oh, good. Thank you, Mr. Schmidt.
Yeah, that's total sarcasm, and I don't appreciate it.
Oh, no, it's not.
Does she treat you guys like that?
Don't tell him. Yes. I
Okay.
like it the way Mr. Schmidt explains things, so that was pretty cool.
Well, I just wanted to
So
see
he
it.
had a third and a half of a third. So
Yeah.
1 whole third and a half of a
because
third.
this division question is really saying how
Yeah.
many thirds are in
Yes.
1/2.
Yes.
And so there are 1 1/2 thirds in 1/2. Okay.
Absolutely.
All
Okay,
right.
so
So now
this
tell them
one
about this.
here, I don't know what to say, guys.
Hey,
This
and
here,
we're not criticizing whoever made the packet.
No,
This
you know
doesn't
what?
look like you're supposed to do any work on this page.
Yeah, the thing of it is I just want you guys to take a look at it because I think we've ran into something like this before, and
we've
we
run
actually
into it too.
yeah yeah thank you. And so we will probably use it in the future.
I would
So-
say this is like, if I had a math notebook, I might put this page in it.
Yeah, definitely.
This looks
Yeah,
like an
definitely
informational page you would put in
Definitely
your
in
notebook.
our math notebook.
Yeah.
Yeah. So we have 54 inches. It says use a chart like this to help organize the discussion. So I have 54 inches. Change in size, half. So I'm going to take the 54 inches. I'm going to cut it in half. Now, half of 54 is 27 and 27. We have the expression over here, half times, which is half of 54, which we know is going to equal 27. We can do it like this.
And should we call out what that is they have at the end? The N?
The unknown.
Well, and also it's called a variable.
Yes.
In this case, it probably stands for number, but it doesn't always, I'm just saying.
Okay, so can we cross cancel here? Yes, we have 2 even numbers. We definitely can. 2 goes into 2 one time. 2 goes into 54 27 times. And 1 times 27 is going to equal 27. So it's 27 over 1, which is what we actually have, 27 inches. So half of 54 inches is 27 inches. Then we have a number line down here that we have the full Monty of 0 to 54, and we want to know what is half of 54. Well, the halfway point right here, 27. Okay, and so down here, what we are doing is we are showing you an area model using fractions, and so we have 2/3 times 3/4. So 2/3. So what makes up? We have 1/3. Well, what makes it a whole? Because we're not going to show a portion of a block here or a square. So it would have to be 3/3. 1/3, 2/3, 3/3. But we're only interested in 2/3 of it. Okay? No, it's not ugly. But we're interested in this 2/3 of it. Multiplied by 3/4. Well, again, we cannot take a piece of it. We're going to use the full square. So that would be 4/4. 1/4, 2/4, 3/4, 4/4. But we're only interested in 3/4 of it. So we're going to go across here. Okay. So now, what we're doing is we're interested in 2/3 times 3/4. So we have our 3/4 over here, and we have our 2/3 right here. Well, what area is being taken up? 1, 2, 3, 4, 5, 6. So 6 pieces are being taken up out of how many altogether? Because we drew a complete square here. So I say that's 6, 7, 8, 9, 10, 11, 12. So there were 12 boxes altogether, and there were 6 of them that were being consumed by the 3/4 and the 2/3. Okay? Now, 6/12. Can 6/12 be simplified, Mr. Schmidt?
Yes.
What should it be simplified to? What can we break 6 and 12 by?
Divide them both by 6.
Thank you. So if I divide them both by 6, 6 goes into 6 one time, 6 goes into 12 2 times. And so it takes up half of it. Well, let's check it out. 1, 2, 3, 4, 5, 6. Okay, so that's 6. 1, 2, 3, 4, 5, 6. Woo. So all of these together equal 6. So it is half of it, isn't it?
Mm-hmm.
So they're just showing you ways to use an area model with fractions.
So why don't you should talk about the second model that they have there? What are they doing?
Well, I think they just flipped it around to show it in a different way, didn't
So
they?
they used the commutative property and
Mm-hmm.
just showed you that no matter which one you use first,
Yeah,
as a factor, you'll receive the same answer.
absolutely. So instead of so up here you have 3/4, and down here you have the 2/3 right here, and so they've done the same thing,
And you
and
have
so
the
you
same
still
area.
see it.
But it's just turned on its
Yeah,
side now.
you see
But it's
1,
still the same amount.
2, 3, 4, 5, 6. Okay, so you have 6 out of the 1, 2, 3, 4, 5, 6. 6 and 6 is 12, so you had 12 total, and 6 of them have both the 2/3 and the 3/4 in them. So it's 6/12 again, which we know will simplify back down to 1/2. Okay, so they're just showing you both ways.
Yeah, they're showing you'll receive the same product
Mm-hmm.
no matter which way you multiply
Exactly.
it. Okay, what about this one?
Okay, so it says
You enjoyed this one.
yeah, I know.
The shoe problem.
Because I just feel like they kind of shortchanged you here a little bit.
And I just want to point
Mr.
out.
Schmidt should probably do this
No,
one.
I'm not going to do that. I just want to say this is one of those where they've already shown you the answer down here. So they don't even expect you to figure it out.
Yeah, but we don't like that.
Well, that's why we're saying this probably belongs in a math notebook.
Yes, exactly.
Yeah.
Okay, so, excuse me. 3/4 of the class, excuse me.
She wants me to delete that.
Okay, 3/4 of the class is boys.
I'm not going to delete that.
2/3 of the boys are wearing tennis shoes. What fraction of the class are boys wearing tennis shoes? Excuse me. Okay, so what we have here is we have this drawn out here already for us. So we know that 3/4 of the class are boys. So I'm going to just say boys. Ooh, that's not good, Mr.
So I
Schmidt.
just want to point out, it's the same problem we had up here.
Yeah, it
2/3
is.
times 3/4. Was this one up here the same thing? No. Okay.
Okay, so I'm going to come down here, and I'm going to say that this is boys, this is boys, and this is boys. 3/4 of them are boys, which means only 1/4 are girls.
That's a
Okay.
scary class
Yeah.
for the girls.
Yeah. I know my girls. They can handle it.
Yeah.
Okay, so out of this, 2/3, so out of this, we're talking about 1, 2, 3. 2 of the 3 are actually wearing tennis shoes. And so that is what is being shown right here. Okay. So if you look at this here, what portion of the entire class is wearing tennis shoes? Well, as you can see, it's half of the class.
Yeah.
Now, Mr. Schmidt says, well, we should be done here because they're not asking you to do anything else.
Oh,
I'm
come
saying,
on.
oh, no way. We're not falling for that nonsense.
Orange Crush and blah, blah, blah.
Yeah, so we're taking it further. So let's look here. Out of half of the class, we have 1, 2, 3, 4, 5, 6. So this is 6. And this is 6. Well, if half of the class is 12, this must be 6 and this must be 6 as well. How many kids are there in this class?
Mrs. Schmidt?
Yes.
Doesn't a person wear 2 shoes? So
Well,
how do we know? How do we know that those represent a person?
No, we're not.
Does it take
24.
2 shoes to represent a person?
No.
Could only
So-
be 12 people in the class.
No, there's 24. 24 students in my class.
Mm-hmm.
Okay.
Well, there's no
And
key
so-
to tell us.
I know there's not. And so that means there are 6 mean little girls. Because you guys can handle all those boys. Okay? There we go.
There we go, but we don't know how many kids are represented by each shoe.
Heavens!
Okay, let's go down. Problem solving.
All right. There are 15 cars in Michael's toy car collection. 2/3 of the cars are red. What is it with this 2/3? How many red cars does Michael have? Okay, so let's go back up here. Let's get red. Okay, so we have 15 cars total. It's still blue. And 2/3 of them are red. Okay. How many red cars does he have? So 2/3 of, which you're going to say multiply by 15. And so 15 wholes over 1. Can we cross cancel, Mr. Schmidt?
Yes.
Okay. So 3 goes into 3 1 time. 3 goes into 15 5 times. 2 times 5 equals how many red cars does he have? 10 red cars. Now, Mr. Schmidt, I know that you want to model this in a different way.
No, I don't need to model that.
Well, why not?
Well, okay, I could.
Yeah.
Okay, so let's see. I would just make a grid of 3 by 5, right? So let me see. 3 rows, 5 columns, and let's see. So I know that it says 2/3 of the cars are red. Okay, so let's make some thirds. I'm going to break this. I'm pretending this is a case of cars because I always used to have cases for my really cool cars, and then I had a box for my cars that I played with in the dirt outside. So I need 1, 2, I know you say 2, 3, 4, 5. Okay, and here's my boxes. These will be bigger boxes for the fire engines and stuff. Okay, so then, let's see if I can do a red highlighter. That's kind of reddish. Okay, so let's say, hey.
Yeah.
Okay, there's, okay, I can still do it. So really, I want this whole row to be red cars, and this whole row. Then I have 2/3 of the cars red. That's a lot of red cars. I mean, if you only have 15 cars and you have this many that are red.
I think that they went through demolition derby and that's all blood.
Now, the problem never tells us what these spots are for, right? What color they are. We just know that they're not red. So how many cars do we have that are red? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cars that are red. Yep.
Looking good, Mr. Schmidt.
Okay, we're good.
Love it, love it, love it, triple love it. Okay, so now let's do the last piece. It says, use the clock to help you solve each problem. How long is 3/4 of an hour? Well, it is we look at this here and we say, I'm going to break it into fourths. And each one of these is 15 minutes. Okay, so each one of them is 15. So if 3 of the 4...
I just want to jump in and help some people. Okay. You guys know, I know most all of you know, this is 5, 10, 15. So that's where she's getting the 15 minutes.
Thank you. Okay.
You're saying a lot of kids in my class don't know how to tell time with a clock.
Oh, I'm sorry. That's true. That's true. So 5, 10, 15. 5, 10, 15. Okay, so 3/4, that would be this one, and this one. So 15 times 3, this 15, so it's 45 minutes. Okay? So 3/4 of an hour is 45 minutes.
Yeah, you guys know that there are 60 minutes in 1 hour, right? Almost everyone knows that. And so 3/4 times 60 would give us 45.
So how long is 3/4 of 2 hours? So again, if I broke my time up, this is just an easy way of doing it. And again, like Mr. Schmidt said, 5, 10, 15. So if I said 15, 15, and 15, that's 3 of the 4, correct? And then I came over here and I did it again, and I said 3/4 of 2 hours. That would be 15, 15, and 15. Well, this is 45, and that's 40, because we already know 45. 45 plus another 45. And it's going to equal 90 minutes. Okay?
Okay. So now, guys, what would you do on the last one? I think we should let them do
Yeah,
the last one.
definitely.
So
So we've modeled this. I think
just
that
cut
you can...
the clocks apart just like she did. Put 15, 15, and 15 in each clock. And then add the 3 clocks together.
Let me go and do this for you here. So, whoops, excuse me. So it doesn't seem too confusing. I'm going to take this 15 out of there. So you can see it's 15, 15, and 15.
Right.
Okay?
I was going to highlight those sections.
Yeah. Oh, that was a good idea. Yeah, so maybe that would have been better.
No, but you have it
yeah.
written in there, so that's fine.
Yeah, so you can see that there. So you're going to do the same thing down here. Take it, break it up. 15, 15, 15. What do you have? Okay? All right. So, I think that we're at the end of it. Yeah.
That's it.
That's it for today, guys. I hope that you have enjoyed our lesson. I know that we have.
And I hope you enjoyed your May the 4th off.
Absolutely. And we will see you tomorrow. Bye.
Thank you for watching, guys. Bye.